As we're ending the semester, we have this chapter and one more after this. But this one is pretty much the culmination, because what we're doing here is when you do a statistical analysis, a research project for probabilities, you will have to, before you get started, you have to think about, what am I looking for? Is what I'm proposing going to increase, decrease, or what are the effects of what I'm doing? With that, you have to state what is called a null hypothesis. For example, let's say you're interjecting a new artificial intelligence app in your math class, and you say, so by the use of this artificial intelligence application, I am proposing that it's going to increase the grades of the students, the content knowledge of the students. So what your hypothesis is stating that with this effect, the end result will be higher than it is now. And there's chapter 8. I'm sorry. Now, so that's where we're going to look at this whole section and this whole chapter, actually. And it's pretty lengthy. It'll take us a couple of days to go through it. And then we'll end up the semester by talking about when our solutions are, they look at the correlations and regressions with respect to our analysis. So first off, let's talk about, what is a hypothesis? You've heard this before. You've heard it, people say the hypothesis is this. Hypothesis is a claim or a statement about a property of a population. Because remember, you're always trying to determine what is happening with the entire population. So hypothesis is that it's a claim you're making about the population. And there are two parts. We'll talk about this later on. There's two parts to it. Now, what is a hypothesis? Test. Hypothesis is a process. It's a procedure for testing the claim about the property of the population, about a property of a population. So what do we mean by property of a population? If you want to close the door, you guys are more welcome to. When we say a property of a population, that's the value of a population parameter. Now, what are we talking about when we say population parameter? What does that mean? That's like the mean, median, mode, variance, deviation. That's one of the numbers that define it. So here's an example. What does P stand for? Not just population. What about the population? Because remember, we also had Q. Something. What is that something? It's okay. We'll just call it a population parameter. So with this, most internet users use two-factor authentication. So P is stating that this is what the population is doing. So what would Q be? If P is greater than that, what would Q be? But since P is not a specific value, if it was P equals 0.05, then Q would be 0.05 because the other P plus Q has to equal 1. The next one we have is the mu is less than 98.6 degrees Fahrenheit. Mean body temperature. The last one is, what does this stand for? Of the population, because it's Greek. Whenever it's Greek, it's population. Whenever it's not Greek, it's a sample. So the sample population, the population standard deviation equals 15. This example could be the population of college students population has IQ scores with standard deviation of 15. That's what it says. Now, this is a reason we're using these three examples. I'll read an example for you. But these are the three different types of testing we'll be doing. Proportion, mean, and standard deviation. We'll focus on those three throughout this entire chapter. Or yeah, mostly chapter. Here's example 1. Consider the claim from the chapter problem. That most internet users use two-factor authentication. Blah, blah, blah. Now, what does that mean? How would you represent that? using proportions. It said most internet users. What does most refer to? How would you signify that mathematically? Of what? Greater than what? 50%. So here, this is what we're saying here. This is how you would take this claim and represent it. Okay. I still haven't had a chance to look at that's what stat disk. So I'll get to it as fast as I can. Hypothesis tests are called tests of significance. Can anybody guess why? What is, remember we talked about significance. How does that relate to what we're talking about here? What do we talk about significance? What does that refer to? How do we relate to that? See if y'all remember 2 weeks ago. How many? Right. It has nothing to do with importance. You can't do that with importance. There's no such thing in mathematics of importance. But standard deviation is with our mean. We have 2 standard deviations to the right and 2 standard deviations to the left. Anything in here is significantly high. And anything, that was a good guess though. That was a good guess. Significantly low. Now, the reason why this is significant is because when we do hypothesis tests, we have 2 types. The null hypothesis, which we'll talk about in a second, deals with the extreme cases. In other words, whether we reject or do not reject the null hypothesis depends on whether our values fall within these significantly high or significantly low regions. And we're going to have names for these. Those are called critical values. Because those are the ones going to tell us whether we keep it or not. In the notes that I gave you, there is this spreadsheet, this flow chart. If you don't have them, they're up here. So the procedures for hypothesis test. First off, you have to identify the claim. What is the claim? Well, it's what the statement is saying. Like the earlier one about most people use 2-factor authentication. That's the claim. Why is that the claim? Because we can't prove it because it's a population. When we say most people, we're talking about the population. So that's saying identify the claim first. Then represent the claim using symbols. And we're going to do all this in a little bit. Identify the null and the alternative or alternate hypothesis. The alternate hypothesis, H1, is the one not containing equality. So H1 will only be less than, greater than, or not equal to. So that's the alternative. HO is called the null hypothesis. The reason it's called the null hypothesis because it's zero. That's what we're using to compare it. This one can be less than equal to, greater than equal to, or equal to. Those are the symbols we use for those null hypotheses. Then we have to select the level of significance. What that's going to do, the level of significance is going to help us determine how big these parts are. These parts at the very end are called tails. And that's usually what alpha defines. That's a significant level. How significant are you? Typically, we use something like 0.05. Remember last chapter, we learned how to find the values. If I gave you 0.05, how do we find the z-score for that? Well, yeah, because we just talked about it last week. Let's see if anybody remembers what we talked about. Okay. Well, remember, now we have tails. We can have 3 different types. A left tail, a two tail, or a right tail. Now, the one that determines which one you're using is the alternate hypothesis. Because what if your hypothesis said something like that? Because it's pointing to the left, this one is a left tail test. If it's not equal to 3, that means it could be below 3 or it could be above 3. So it's a two-tail test. That's what I was afraid of. And then the last one would be X is greater than 3. Because it's pointing to the right, this is a right tail test. So that's why it's important. Once you state your hypothesis, your null hypothesis, that automatically determines what your alternate hypothesis is, and that determines your graph, your tail test. all you have to do is you select. This is where you come in totally also. You select how significant you're going to be. How confident, because what you're doing here, you're creating a confidence interval. How confident are you that the population information will be within this interval? So that's why you select this alpha. And then we can move on here. Then the fifth step, identify the test statistic. What that means is, are you using the p-value? Are you using the mean? Are you using the deviation? Are you using z or t? So that's, you have to determine that. So now what you have to do here is, if you're using a p-value, the p-value is determined by the level of confidence you have, the alpha level. So from there, you make a decision. On your test, you're doing that. And on the other side is the critical value method. The critical value method is, once we define the two-tail or one-tail test, if our value falls within here or here, then we fail to reject, or no, this is where we reject the null hypothesis. If it falls inside here, we fail to reject the null hypothesis. Remember, it all boils down to what your null hypothesis is. Why is the null hypothesis so important? Because it's a statement that you're claiming about the population. So if it's inside one of these tails, if your answer that you calculate falls within these tails, in other words, if it's greater than this critical value or less than this critical value, then we fail to reject the null hypothesis. Notice it doesn't say keep the null hypothesis. It simply says that we cannot reject the null hypothesis. Why? Because a null hypothesis would need further testing to see exactly what it entails. Now, if the value falls in this insignificant region, it's not significantly high or insignificantly low, then that's what we fail to reject it. Then we make our decision, and then that's where we make our conclusion. So that's what we're looking for here. So what is a null hypothesis? That's indicated by H sub 0. The null hypothesis is a claim or statement about a population that the value of the population parameter, remember that's the mean variance deviation, is equal to some claimed value. Remember, Your null hypothesis, it's a hypothesis. Yes, it's a statement. But the value of what you're looking here is equal to some claimed value. There's using method XYZ will increase students' score. So what I have to say here, it'll make the grades higher than 70 or higher than 90. The alternative hypothesis, labeled as H sub 1, is a statement that the parameter has a value that is, or that differs from the null hypothesis. Remember, null hypothesis when you make a statement of the null hypothesis can only have these symbols. Null hypothesis can only have those symbols. Oh, for a null hypothesis, you can say that this is I forgot about this. It's a working assumption. That's what you're basing your whole study on. Example. This is an example of a proportion. The proportion of the population is 0.05. Or that's proportion. Remember, we also have mean and standard deviation to talk about. So the null hypothesis, if it was the mean, it would look like something like this. I'm referencing back to what we had earlier when we talked about these three possibilities: the proportion, the mean, and deviation. So I'm stating the null hypotheses. And the null hypothesis for the standard deviation would be 15. Those are examples. So what would the alternate hypothesis look like? If the null hypothesis was for proportion, what would the alternate hypothesis look like? Put that stuff up. You're not in beauty school here. Remember the symbols that alternate hypothesis have to use? So if that's equal, then we can say this is not equal. Same with the rest of them. If the mu is 98.6, then the alternate hypothesis would be the mu does not equal 98.6. And the standard deviation equals 15. So the alternate would be does not equal 15. Does it always have to be equal, not equal? No. For example, my alternate hypothesis here, I could have put, depending on my how, I could have put that it's greater than 0.05. It doesn't have to be, if this is equal, this is not equal, because I could be specifically looking for one-sided only. All right, so that's a possibility also. All right, so now let's look at significance levels. Remember, we looked at, where's our chart? When we looked at our chart here, step 4 said do what? Because we identified alternate hypothesis and null hypothesis. We figured out the fall. Now in step 4 it says select significance level. What does that mean? Step 4, select significance level. The significance level is alpha. What the significance level talks about is the probability of rejecting the null hypothesis when the null hypothesis is true. What does that mean? The probability of rejecting the null hypothesis when the null hypothesis is true. When would we, how, with our test, let's say we have a two-tailed test. This is CV1, critical value 2. Which part of that would we reject the null hypothesis? Remember, the null hypothesis has to be what? Equality, equal to, greater than, equal to, or less than equal to. So for in the two-tailed test, the alternate hypothesis would be, let's say, P is greater than 3. We could say that's over here. So if it's inside here, we fail. No, we reject the null hypothesis. If it's inside the critical region, well, I should have told you that. This is called the critical region. Those are the critical regions are the significantly high and significantly low areas. So both of these are significant regions. They're determined by the critical values. Are the critical regions, I mean. They're called critical regions. That's critical value. If it's inside here, if the value we get is inside here from our test, then it's not significant. So here we fail to reject the null hypothesis. So that's what I was looking at here. So what we have to do is we have to determine how sure are we of this is the critical region we're looking at. This is the critical region. Just defining it. So the alpha can, if it's 0.05, then we're 95% sure the population value will be within the confidence interval. Oh, that's an old word from the past. What's a confidence interval? How do we find the confidence interval? There's an interval. So we have to figure out what these two values are here. That's a two-tailed test. So if we have a two-tailed test, that's a come in the past, we divided it by 2. And then we use this value to find the z-score and the z-score will tell us the area that part entails. So review your confidence interval, but that's where we first learned about alphas, the significance level. Okay, step 5. Where's my chart? Step 5 said identify the test statistic. So step 5 says identify. Now, what are your options? What test statistics can you choose from? Proportion, mean, standard deviation. Well, these are your parameters that you can choose from. Depending on which parameter you have, the sample distribution, the requirements, and the test statistic. So the test statistics depends on which parameter you have. If you're dealing with proportions, that's the P. It's got to be normally distributed. And we use the z-score. So what are our requirements here? N times P has to be greater than equal to 5. And N times Q has to be greater than equal to 5. Or 0.5. So if that's the case, remember, we got to use a z. And we use this formula we talked about not too long ago. P hat minus P divided by the square root of P times Q over N. We've seen these before. We're not putting them all together. So if you're dealing with a proportion, we have to use a z-score, and we can only use it. We have a valid answer if these requirements are true. The next one, the mean, population mean. The sample distribution here is we're going to use the t-test. Now, what are the conditions for using a t-test? One, the standard deviation is not known, and it is normally distributed population, or we can look at these other conditions. Where the standard deviation is known and our sample size is bigger than 30. Now, why is that important? If we don't know the standard deviation of the population, that usually means we have a very small sample. And it's normally distributed. So that's very important. It has to be symmetric. Population. Or if we do know the standard deviation, then our sample size could be large. Typically, it's less than 30 or equal to 30 and greater than 30. So our t statistic is, remember, because we're dealing with smaller unknown and deviations usually not known, then we have to use a sample. So we use the x bar minus the mu over s divided by square root of n. We have another condition. If we're going to use the mean, the mu, and we use a normal distribution, we can use the z-score here, the z-test. The conditions for the z-test is one, the standard deviation of the population is known, and population is normally distributed. What that means also, normally distributed, is there aren't any outliers. So if we use a z-score, or the standard deviation of the population is known, and n is greater than 30. So we use a z-score, which is x minus mu. Since this is z, we know the population. So this is the difference between the two, the z and t. The standard deviation of the sample, standard deviation of the population. And the last one, the third one, is the standard deviation or variance. Standard deviation is rho, and the variance is rho squared. We did that in the second week of class, or third week of class, when we did the calculations. If we're doing the standard deviation, then we use something called chi-square. We'll use that test. Has to be normally distributed. That's the only condition. It has to be normally distributed. The formula for chi-squared is n minus 1 times the sample standard deviation over the population deviation. Let's look at an example. Good. This is step 5, because you have to figure, because this will give us the value we need. Because we already calculated, we did the hypothesis test, we determined the critical values. Now this gives us the value that we have to compare it to. Here's an example, a discussion example. The claim, the proportion is bigger than 0.5 is a claim about the population proportion P. So we use the normal distribution only if the requirement are satisfied. The requirements we had in our list, the requirements are n times p have to be bigger than equal to 5, and n times q have to be bigger than equal to 5. So if we had n equals 926, p is equal to 0.05, That means Q is equal to 0.05. Then N times P equals 926 times 0.5 is greater than 5. N times Q, 926 times 5 is also greater than 5. Now, because those conditions are met, we can go ahead and progress with that. Once we choose the test statistic, we have to use it. So once we choose the test statistic, we have to go ahead and calculate it. Because now comes the actual test itself. Step we just did. Find the value of the test statistic. Once you find that, then find the p-value for critical values. Test statistic is a value used in making a decision about the null hypothesis. So it takes a sample statistic like p hat, x bar, or a standard deviation of a sample, and converts it to a score, a z-score, a t-score, or a chi-square. Assuming the HO is true. Remember, why do we assume that HO is true? Because that's the claim we made at the beginning. Whenever we do anything statistically, we make a claim. That claim is automatically your null hypothesis. If it involves equality. If it's a strict inequality, then you just define the H1. All right, let's look at an example. Okay, from the first example, we have a claim about the population proportion P we have N equals 926 and P hat is equal to 0.52. The null hypothesis stated that P is equal to 0.05. So we're working on the assumption that P is equal to 0.05. So from here, what is our Q? Since we have a P, we have to know Q. Well, yeah, it's 1 minus P, which is 0.5. So we have P and Q. We have P hat is 0.25 or 0.52. We have N. What else do we need? Oh, we need an alpha. Well, I said majority of the time, whenever you see an alpha, use alpha equals 0.05. That is the most common, if you ever read a research journal, you'll see that the alpha used, the level of confidence, the confidence interval is 0.05. What is the z-score? Which means the test result. How do we find that? What's that? That's one thing there's two ways we can do it. Let's look at both ways. We know what the alpha is. We can find through the chart, or we can use the formula. If we use the formula, we got P hat minus P over PQ over N square root. No, here we don't need the chart for this one just yet. We don't use the chart. What we can use though we can use p hat versus what do we have? We have our value in other words, we can calculate p hat, or we can use the value of this value p. Where is that? The p hat here. What I'm saying here is this. If we use just p hat, that's just saying it's 0.52. As opposed to, if you use the formula, we can use n times p over n. Which is 926 times 0.52 over 926. Yeah, so this is, in our case, it's 926. But what is n times p? N times p is 926 times 0.52. Calculate it out. So we have 926 times 0.52. That equals 482. So for this value here, instead of p hat, we can use 482 divided by 926. What's that going to give us? This gives us 0.52052. Actually, it repeats itself forever after that. Notice, if we use this in place of that, let's calculate the z-score. So we put 0.52052 minus p, which is 0.5, divided by 0.5 times 0.5 over 926. What's that going to equal? Don't just sit there. I mean, do something instead of just sit there staring. So I have 482 divided by 926 divided by the square root of 0.5 times 0.5 divided by 926. That's the one you have to use. Yeah, that's what I had. That's what I'm getting to. We're gonna use both of them. We use this one and this other value. And the reason being because accuracy is what's gonna happen is yeah, and that's why I don't like students looking at that when I'm doing this, because you're gonna be two different things. I'm not going the same way. So that's what stuff there. Minus 0.5. There. Using this formula. Using this formula with this value, instead of just straight up 0.52, we get 1.25. Yeah. If we use 0.52 minus 0.5 divided by these numbers, .52 minus 0.5 divided by square root of 0.5 times 0.5 divided by 926. This one gives us 1.22. So we have a considerable difference in values. There are z-scores. Why does that make a difference? Huh? No, but what difference do these values? They look pretty close, don't they? They're 3/100ths of each other away. But what difference do they make? Of what? What do these numbers represent? It represents the value, the critical value that tells us the area. Because now if we look at our z-score chart, 1.22 is 0.8888. 1.25 is 0.8944. So this one gives us a better chance of making sure that our population value is within our range, is within there. So we would not use this one, we would use this one. So as we talked about, we have the critical values here. This is a critical value. What they do is they separate the significance and non-significance. So what that means, it defines these areas here. These are called the critical regions. So what is a critical region? The critical region is the area on one or both sides that corresponds to all values of the test. Ah, statistic that makes us the region makes us reject the null hypothesis. The critical region is the area that corresponds to the values that of the test statistic that makes us reject. This is important. If once you find your critical values, if your z-score or whatever test you have, if it falls here or here, if it falls in there, then we reject the null hypothesis. So if it falls inside the critical regions, we reject the null hypothesis. If it falls inside here, we fail to reject the null hypothesis. It doesn't mean we accept it. It's just that we don't have enough information to make a determine one way or the other. It's just that we cannot reject it. How do you determine whether it's a one tail or a two tail test? If it's a right tail or a left tail? Which one? Of what? You're right. It is a sign. It's the inequality signs, but of which one? The determination of which one of these graphs you have is determined by the alternate hypothesis. The direction the inequality points. There's no equality anywhere here. So it's the alternate hypothesis. So that's come the very first step you have is you have to determine what is the null hypothesis. Once you have the null hypothesis, then you calculate the alternate hypothesis. Once you have the alternate hypothesis, you know what kind of test it is. If it's pointing to the left, it's a one-tail left test. If it's not equal to, that means it could be in either end, then it's a two-tail test. If it points to the right, then it's a one tail right test. And again, the shaded region is called the critical region. If your value, your test value falls within that critical region, what do? Reject what? Right. If your test value falls inside the critical region, then reject the null hypothesis. Because you never ever, you don't state anything about the alternate hypothesis. It's always in reference to the null hypothesis. So we have three methods. Because this test value the first one is the proportion method. Where you find a p-value. What is the p-value? The p-value is the probability of getting a value of the test statistic that is at least as extreme as the test statistic obtained from the sample data. Here we have the flow chart for it. So what type of test? Is it left-handed, right-handed, or two-tailed? If it's right-handed, well, how do we determine if it's right-handed? The alternate hypothesis is a statement that says P is greater than. So if it's P is greater than some number, we use this way. If it's less than some number, we go this way. If it's not equal to some number, we go this way. And we'll pick up from here next time. Yeah, so we're halfway through this. But we have two other ones. We have the means and standard deviations, and actually four, and chi-squares. So this determines what we do and how we find it. And here's the worst part while you're packing. P-values aren't used in the professional world. Because it's so easy to cheat and lie with these. They're not used in the professional journals. But we have to teach them anyway because it is one of the processes. So page 9, we'll start from here next time. All right, go enjoy the sunlight and get some free food, pizzas. They still have those? It looked so good. My stomach was grumbling when you were eating away. Where are they at? Here? Oh, yeah. With it, yeah. Okay, thank you. What did you forget? Ooh, that's not good.
But I didn't want to think I was gonna want to use it.
Just did.
Hi, Professor.
Hello, what you got?
By chance, did you link the packet of notes in the remind this past week?
Actually, I printed them out and I brought them here.
Okay, okay. I was
no,
having trouble today, so I just joined the Zoom meeting instead.
Okay, oh, actually, I'll go ahead and I'll get them to you tomorrow morning because I have a meeting to go to Denton first.
Okay.
So I will.
I can see you Thursday.
Okay, yeah, I'll get them to you by Thursday because I have to scan them first and send them to you.
Okay. Okay, perfect. Thank
All right,
you.
you're very welcome. Bye.
See you Thursday. Bye-bye.